Hello, good morning everyone. So, as you remember, in the last class, we did this problem, right? Alright. So, I hope everybody understood this problem. And if you have any doubt, you can let me know. Else, we shall carry forward to the next problem, which is this, right? So, let's do this question as well. So, read this question. So, what do we have here is that there's a point here. Let's call it P. Oh, one second. Sir, some overlay problem. I'm writing here, it is coming in this way. Can't we delete this app? Okay, so what do we have here is that the angle subtended by the moon's diameter. So what is the moon's diameter here? Angle subtended by the moon's diameter, right? So moon's diameter is this, D, right? Which is given to us. Angle subtended by the moon diameter at a point on the earth is about these many degrees, theta. So at this point, the angle subtended theta is given to me, right? Is this. Use this in the fact that the moon is these many kilometers away from us. So we'll call this distance r, the distance of the moon from this point P from where we are observing. That distance is given as r. And that's theta is given, r is also given, right? And you are being asked to find out what? To find the approximate diameter of the moon. So diameter you have to find out, right? Now to find out diameter, now you can see that this is like what? It's like a arc. This is the arc length. This is the arc length. And that arc length is subtending how much angle here? Theta. Right? And you have to find the value of D. So what is the formula that we have learned? Arc length theta is equal to what? Arc length divided by radius. And in this problem, arc length is nothing but the diameter. So it will become diameter upon radius. And you have to find the value of the diameter D, right? So what is D coming out to be from here? Theta is equal to D upon R. Well, and that gives me D is equal to R into theta, right? So that's how we can find the value of D, the diameter of the moon, right? So I hope the process is clear to you, the formula is clear to you. Now all we have to do is substitute the values of R and theta here and get the answer. So let us start with the calculations. So let's put the value of R. What is the value of R? Oh, one second. The value of R is uh, see, the value of R is given as 384,000 kilometers. Now, as you kids know, As you kids know that this is given in kilometers, right? And now my question is this the standard unit? Because you see all calculations are supposed to be done in the standard unit, right? So if it is not in the standard unit, we have to make sure that it is in the standard unit. Now, is this in the standard unit? Is your uh, R, is it in the standard unit or not? So you'll see that it is in kilometers, right? It's in kilometers. And it is to be converted into standard unit. Everything has to be converted into standard unit, kids, right? Everything has to be converted into standard units for calculation. So R, which is in kilometers, has to be converted into meters, right? Likewise, theta. Now theta is given in some angle. Now what is the standard angle of theta? It is not what is given. What is given? See, degree is given, right? So can we use degree? No, we have to convert it into radians, right? So let's convert it into radians, and then we can use it. So R is given to me. Theta I have to find out in radians. Let's convert both of them in the standard units. So what will be R? It will be equal to 384,000 kilometers, and kilometer is nothing but 1000 meters, right? So that gives me approximately 384 into 10 raised to the power 6 meters. Now our problem is solved, right? So our problem is solved because now we have obtained R in terms of meters. But the problem of theta is still not solved because theta is still given in what, guys? Theta is still given in degrees, right? So that needs to be converted into the standard angle. And which is the standard angle? As we have been doing, the standard angle is radians, right? So let's convert it into radians. Now theta is, how much is theta given? It is 0.5 degree, which can be written as 1 by 2 into 1 degree also, right? And why am I doing that? Is because I want to put the value of 1 degree. Okay? And what can 1 degree be written as? See, we have done it in the last class, if you can remember. We saw that 1 degree is nothing but pi radian upon 180. Pi radian upon 180, right? That's what theta is equal to. So we can get theta from here, and that's coming out to be pi by 360 radian, right? So with theta also there, we can put the value and get the value of d. So R is how much? 384 into 10 raised to the power 6 meters into theta, which is pi upon 360 radian. And then again, you can go ahead and do the actual calculations and get your answer matched with one of these. That's one way to go about it, you know. And the other one is to do the crude calculation, which I told you about yesterday. So that's also something we can do. So let's do the crude calculation because the actual calculation you can do yourself. So I'll do the crude calculations. Or let's first do the actual calculation. So you kids try doing the actual calculation and see which option are you getting. And then I'll do the crude calculation. So if you do the calculations, you will get the B option, right? And now I'll do the crude calculation. So I write down here crude calculation. Let me show you crude calculation. See, 384 is almost as good as 360, very close. You can cancel them. So what is left? D is almost coming out to be how much? Pi is there, guys. Pi is what? 3.14 into 10 raised to the power 6. And then meter it will come. The unit of D is in meters. Distance, diameter is unit is meter. Standard unit. So what is it coming out to be? That is 3140 into 10 raised to the power 3 meter, which is like 3140 kilometers, right? And that is very close to the B option. Got it. So that is how you can do the calculations without even without doing the actual calculation. Using crude calculations, you can get the answers quickly, right? So it's quite advantageous that way, right? Now take this down and we'll move ahead. So let's go ahead to the next problem, which is this. Sun's angular distance is measured as this. Again, theta is given. The distance of the sun from the earth is also given. This. Again, R is given. What is the diameter of the sun? So you see it's the same problem, right? Again, they're asking diameter. Exactly same problem. This was D. This is R and this is theta. And we again know theta is equal to what? Arc length upon radius. And you see this is the arc length again, like we did in the last problem. Which is D upon R. So what is your diameter you have to find out? So D is coming out with what? R into theta. And R is already given to you. And theta is already given to you. Right? Now the problem is theta is given in which units? In double dashes there. Double dashes unit of signifies what? So that tells me that this is nothing but 1290. Double dash means arc second. Right. So theta is given in arc second. That's the problem. We'll have to convert it into which unit again? As you know, the standard unit of angle is radian. So you'll have to convert it into radians. So 1 arc second is how much? You have to convert it into radians. In radians you have to convert, and then you'll get the answer. And you have to proceed the same way like we did the last problem, right? So try doing this yourself. Since you've already done a similar problem, try converting 1 arc second into radians. So how much was 1 arc second? Yesterday we found out. So let's use that value. So yesterday we found out that 1 arc second is 485 into 10 raised to the power minus 6 radians. That's what we found out yesterday, right? So using that value, that gives me my theta, right? So I've obtained my theta, and r is already given to me. R is this value, right? So with the help of that, we should be able to find out the value of d. Okay. So let's see what is d coming out to be. D is r theta, r into theta. R is how much? R is that value. 1.496 into 10 raised to the power 11 into theta. Theta is 1920 into 485 into 10 raised to the power minus 6. That is meters. That's radian. And we know since d is diameter, its unit will be meter. So if we just multiply everything, we should get the answer, right? So try doing this calculation yourself and tell me what option you're getting. Or find it out for yourself which option you're getting from here. So let's multiply the values. It will be 1.496 into 1920 into 485, and that gives me 139, or we can write it simply as 1.4 into 10 raised to the power 1 2 3 4 5 6 6 1 2 3 4 5 6. Yes. So this is what we are getting by multiplying all these numbers, these three numbers. And then what is left over, guys? 10 to the power, how much is left over? 10 to the power 11 minus 6, right? Into meters. So we are getting almost equal to 1.4 into 10 raised to the power 11 minus 6, and then this plus 6 will also get added, right? Plus 6, and those two will get cancelled, and we are getting which option approximately? The C option in meters. So take this down, then move ahead. Now, what is a unit of measurement of solid angle? So, as we have seen, the unit of measurement of solid angle is steradian. So, this we have already seen before, right? Now, what is the unit of measurement of intensity of light? So, this also we have seen. Check and tell me which option is this. It's candela. Now, let us see derived units. So, all physical quantities whose unit can be expressed as combination of base units are called derived units. Like example, speed. Speed is equal to what? Length upon time. So as I told you, length and time are which quantities? These things are base quantities. This is base quantity. This is base quantity. Right? So what do we get speed as? Speed is based on length and time. So speed becomes which quantity? It becomes a derived quantity. Right? So can you give me more examples of derived quantities? Like area. Area is what? Length square. And length is which quantity as I told you? Length is base quantity. So this area becomes which quantity? A derived quantity. Right? So that's what this statement says. A physical quantity whose units can be expressed as combination of base units are called derived physical quantities. Thus, all quantities that are other than the 7 base quantities are called derived quantities. So, if you remember, we saw a list of 7 quantities here. We saw a list of 7 quantities, right? Length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. So, anything apart from these will be called derived quantities. Anything apart from these and these two are called derived quantities because these are also fundamental quantities, supplementary fundamental quantities. Other than these 7 and these 2 more, that makes 9. These other than these 9 quantities, everything else falls under derived quantities. Right? Now, can you give me more examples of derived quantities? What are more examples of derived quantities? What about acceleration? Acceleration is, speed by time basically. So that will also become what? Acceleration will become which quantity? This will become derived quantity. Why? Because it is dependent on speed and time. Right? So acceleration also becomes derived quantity. What about speed? Speed was also derived quantity. Acceleration is derived from speed. So that makes acceleration also derived quantity. Anything other than the base quantities. Force also naturally becomes what? This also becomes derived quantity. Right? And then you have momentum, also derived quantity. Right? What else is derived? Charge. Charge is also derived quantity. Right? Why is charge derived quantity? If you are wondering, let me tell you why is charge a derived quantity. It is because current is equal to what? Current is equal to charge upon time. So charge is equal to what? Current into time, right? And this is current. This is current, right? And charge is made up of current and time multiplied together, right? So charge becomes derived because current is already fundamental. That is already base quantity, and this is also base quantity. Right? So charge had to be a derived quantity, right? Take this down. Got it? Okay. See here, if you multiply all these numbers, no? So I missed a couple of zeros. So when you multiply, you get uh, you get D as this option 1.39. You can multiply this and check for yourself. If you want, we can do it by the crude calculations. You can do it by calculator, or we can do it by crude calculations if you want. So let us do it by crude calculations, because you see, multiplying this in the exam could be quite difficult. They are very big numbers, no? So let us see how to do it by crude calculation. Because one of you are requesting me to do it by crude calculation. That is much faster calculation than by calculator also sometimes, right? So let us see. Uh, First, you guys give it a try. How to do it by crude calculation? Because I did by calculator, so some of you kids wanted by crude calculation. First of all, you try it by yourself. How can you do it by crude calculations? I'll just give you a hint. See, what you can do is you can take this value as what? 1.5. Almost it is around 1.5. You can take this value as how much, guys? Is almost around which value? 2000. And this 485 you can almost take it as what, guys? As 500. Right? So that's how you can make it as crude as possible. Now try doing this. Now it has become so simple. Multiply and check what you're getting. And this is, oh, so we are getting we were getting this option. No, we are getting C option because you see, but actually the option is A, 10 to the power 9. We are getting 10 to the power 11 before. You know why? Because I put the wrong value of arc second while copy pasting. I forgot to put a decimal here, right? It is 4.85 into 10 to the power minus 6. That is why I was wondering why I'm getting two times. It is 4.85, guys. I forgot to put that decimal there. Right. So here also I forgot to put a decimal because I copied it wrong there. I'm putting back a decimal. Okay. So if I put a decimal, it will not be 500. It will be how much, guys? If I put a decimal, it will be instead of 4.85. This can be approximated to what value? So 5. You know. So now let us solve it using the crude calculations and with the correction of putting a decimal, which I forgot in the last case. Now get the answer yourself. See, this is 1.5 can be written as 3 by 2 into 10 raised to the power 11 into 1920 can be written as 2000 into 4.85 can be written as 5 into 10 raised to the power minus 6. And what will be the unit, guys? Since you are finding D, the unit will be meter. So let's see what does it come out to be. So this 2 gets cancelled with this and making 1000 here. And this 3 and this 5 will become 15. 15. And now let's collect the powers. So into 10 raised to the power 11, 10 raised to the power 3, 10 raised to the power minus 6. Everything's taken into account. 5 and 3 becomes 15. 10 to the power 11 plus 3, 11 plus 3 minus 6. Everything's written, guys. You know. And unit, of course, it will be meter. So D is coming out to be. Okay, they have in decimal. So 15 can be written as what, guys? It can be written as 1.5 into 10 into 10 raised to the power. How much will be this? 10 to the power 8, right? Meter. And then what are we getting the answer as? D is coming out to be 1.5 into 10 raised to the power how much? 8 and 10 will combine to make 9, right? And we're getting which option? We're getting the A option, right? Not the C option. So you can take down the crude calculations, those who are asking for it. So let us go to the next topic now. And here we had seen the derived quantities, right? What are derived quantities? And we saw some examples of derived quantities. Now let's go ahead and do this system of units. So let's see what a system of units. In this system, centimeter, gram, and seconds are used. In the CJ system, centimeter, gram, and seconds are used, right? So there are basically three system of units. One is CGS, another is FPS, and MKS. And the standard system is made up of MKS only, basically. So what do we have in CJ system is, in this system of calculation, in CJ system of calculation, we use centimeter, gram, and second. As the name suggests, C for centimeter, G for gram, and S for second. Similarly, we have something called FPS system. In this system, we'll only use foot, pound, and second. As you can see, foot, pound, and second. But we don't use this system. We use this system, but we don't use it. We don't use this system. Then MKS also we use meter, kilogram, second. You can see meter, kilogram, second, right? Then there is something called SI system. So SI system is interesting. So SI system already contains MKS, and then also contains more units, and then also contains more units, right? Like which one? So see, MKS contains meter, contains kilogram, contains second, which sorry, SI contains meter, kilogram, second. But you will say the same was contained by MKS also. So what has SI system has got something extra also. SI system has something extra, and what is that extra? That extra is ampere and electric current and Kelvin, and also candela. So you see there are total how many fundamental units? If you exclude the supplementary ones, there are seven. So one, two, three. This is there in MKS also. Then this is extra. So this is extra. What is extra? Ampere. Fourth one is extra. Current, Kelvin, and mole. These guys are extra. And the total make how much? Total make 7 quantities. And when you combine all those 7 quantities, what you get is called the SI system. Standard International, or system international. Actually, the correct full form is international system or international units. It's not standard international, actually it's system international. Fine, you can take this down, because these are the units that will be using in our, these are set of units we'll be using in our calculation. Mostly we'll be using this ones. This is important, this is important, this is what mostly we'll be using, and then this is also fine, but this, no, FPS will not be there. Like, take this down, then we'll move ahead. Let's go ahead. Now let's do this problem. What is the full form of SI? It is Standard International. No, it is System International. That's straightforward, right? Now, which of the following is not a system of unit? So we have got a bunch of system of unit. Which one is not? MKS? Yes, it is. CGS? Yes, it is. SI? It is. Decimal? No. So that's the correct option. Decibel is not a system of unit, right? Decibel is a unit of something you'll study later on in the sound chapter. It's a unit of loudness. Which of the following matches with the SI system unit? So which is similar to the SI system unit? I told you uh, SI contains MKS and it contains ampere, then mole, then candela, and one more. Which one is it? So we had seen how many in this ampere, mole, candela, and also for current A. So these all four guys, sorry, seven guys. MKS has got three, right? Meter, kilogram, second. So this and these guys combined together make SI system. So what will be the answer for SI system? MKS is similar to SI system. American system is your FPS, right? Which we don't use. American system is FPS. Take it, take this one. Now, which one is a measurement unit of measurement of solid angle? This you have seen already. It's steradian, right? Now we come to dimensions. So let us see what are dimensions. Dimension of physical quantity are the powers to which base quantities are raised to represent a derived unit of that quantity. There's a seven dimension of physical quantities. So you have to just remember the notations. For mass, the dimension that is used is m. Length it is L, time it is T, current it is A, temperature it is K, and CD for luminous intensity, and MOL for amount of substance. You just have to remember these, and it's very easy to remember, right? M for mass, L for time, L for length, T for time, A for ampere, K for Kelvin. CD is difficult anyway. We don't use candela. Like you can kind of ignore candela luminous intensity. It's not there in 11th and 12th syllabus. So you can kind of ignore. And mole is self-evident, right? Self-explanatory. So these guys, if you just remember, we'll be able to talk about um, we'll be able to talk about the dimensions, right? So let's see. Let's take some examples. You will understand. So it's very easy, but the time's almost about to be up. So fine, you take this down. Dimensions will start next time. I'll just give you a brief idea. Let's say length. Sorry, let's say speed. The speed is what, guys? length upon time. Okay, fine, check it, because if I start explaining it will take more time which we don't have, so we'll do it next time. Here we go, just copy this. So next time we will do in detail, we'll take examples of dimensions and we'll see how to apply them in problem.